Hi everyone, so today we're going to be doing notes on section 5.6, which is graphing linear inequalities. Now I abbreviated the inequalities to be INEQ instead of writing out the full word, but if you prefer to write out the full word instead, that's totally fine. Go ahead and pause this real quick and write it down, and then I will walk you through it. All right, so step one for graphing these is to graph the boundary line. This is going to be graphing it exactly the same way as a straight line, the y equals mx plus b. The only difference here is whether we're drawing a solid line or a dashed line. So when it is greater than or less than, when that's our symbol, it's going to be a dashed line. So whether it's a positive slope, a negative slope, a horizontal or vertical line, vertical or horizontal line, it will be a dashed line. Whereas if it's greater than or equal to or less than or equal to, it will be a solid line. So that or equal to is what changes it now to a solid line instead of dashed. Step two is once you've drawn your boundary line is to test a point that is not on it to determine if it's a solution to the inequality. If it is a solution, you're going to shade towards that point that was true. If it is not a solution, you're going to shade the other direction. This will make a little bit more sense once we actually do an example. So first, let's do one of these where it is one of the special cases, the horizontal and vertical lines. So first off, y is less than or equal to -3. Is this going to be a horizontal or vertical line? Good, you should have said horizontal line. It's going to go through the y-axis, so it'll be like this, that orientation. All right, next question. Solid or dashed? Good, you should have said solid. This has an or equal to in the inequality, which means it is a solid line. Now you have a choice here of either writing out your graph yourself and drawing them, or you can use the little graphs that I uploaded for you. I just printed out that page and cut out each graph individually so that I can stick them onto my notes and it'll look nice and neat. All right, so what I'm going to do now, y is less than or equal to -3. I labeled my x and y axis, so I make sure I graph this correctly and tape it down on the paper correctly. So it goes through the value y equals -3, and it is a solid line. So I'm going to draw a solid line going through at y equals -3. All right, now the part where it's shaded above or below. If this is saying it's less than, if I were to take an educated guess, less than, I would guess it's below. But I want to show you what this means when I say choose a point that's not on your boundary line. I always like to go with the point 0, 0 whenever possible. And 0, 0 here is way up here. It's above the line. So I'm going to choose 0, 0. And if I plug that into my inequality, I'm going to have 0 is less than or equal to -3. Is that true or false? Good, you should have said false. 0 is not smaller than a negative number. So this is false. Get another color. This is false. So we shade away from 0, 0. Because that point 0, 0, this point right here, that was false. It cannot be included in the solution, which means I'm going to be shading down here below the line. Now for shading, I'm going to use a pen, but if you want to use colored pencils or just use a pen or your pencil and shade it in, But I'm just going to shade that all the way across, and it's really obvious what direction that gets shaded. All right, I'm going to go ahead now and use double sticky tape. If you have regular tape or a stapler, do whatever you want to somehow attach this graph into your notes. All right, so I glued mine on here. This is also why I said to make sure you label the X and Y axis, because it made sure I taped it into my notes the correct direction. All right, let's look at another example. Oops, there we go. So first off, solid or dashed? Good, you should have said solid, because this has an or equal to, so it's going to be a solid line. Now this one, we are going to graph this exactly the same way as our equations in the form y equals mx plus b. The only difference is the inequality. So what's my y-intercept? Good, you should have said -1. And what's my slope? Good, you should have said either -3 or -3/1. All right, so I'm going to take another graph, plot my y-intercept, 0, -1. Notice my x and y axis are labeled again. So label my y-intercept, and then I'm going to use the slope to get another point. So you can either make the 3 be negative, so down 3 to the right 1, down 3 to the right 1. Remember, I always say minimum of 3 points to graph these. Or you can make the 1 negative and go up 3 to the left 1, up 3 to the left 1. Either way works, whichever you prefer. So this line is also going to be solid. So connect all the points. There we go. All right, now I need to look at what direction this is going to be shaded. This is saying it's greater than, so if I had to take a guess, I would guess it's going to be shaded above, which would be this side, but I'm still going to double check just to be sure. All right, so let's look at this now. For choosing a point, you could still choose 0, 0, but depending on how far apart your grid lines are, if you're using my graph, it's really easy to tell 0, 0 is not touching it. But depending on if you hand drew this or if your grid lines are a lot closer together, it might be harder to tell that 0, 0 is not on it. So I'm going to choose a different point. I'm going to choose 1, 1. That one's a little bit more obvious that it is not on the line. If I knew that everyone was using a grid that looked like this and their graphs look like that, I would have chosen 0, 0 again. All right. So we are choosing 1, 1. I want you to go ahead and solve this on your own. Plug in 1, 1 to your inequality and see what you get. So go ahead and push pause, and then when you're ready to check, push play. Go ahead and check your answer. You should have gotten 1 is greater than or equal to -4. Is this a true statement? Yes, it is. 1 is bigger than a negative number, which means we shade in the direction. Where am I going to glue that? Glue there, from. Shade in the direction of the point we plugged in. So we are going to shade towards this little pink point over here because it was a true solution, which means that point is part of the solution. So this one, I'm going to shade everything that's over on this side. Again, you could do this with a pen, a pencil, a highlighter. Just make sure that it's shaded in. Now what this shaded area represents is I could pick any single point over here in this blue area and plug it in and it would be true. I could pick any point over here in the white area that's not shaded and it would be false if I plugged it in. So the blue shaded area, that's what it means. Every single point over here where it's shaded blue is a solution, is true when you plug it in. All right, I'm going to go ahead and stick this down. Let's go ahead and look at our last example for the notes. So what we're going to do now is we have to put this in slope-intercept form first. Actually, before we move on, I just realized the last example we forgot to highlight. It's shaded above. I just realized we forgot to highlight that. Sorry about that. All right, back to this example. So first things first, solid or dashed? Good, you should have said dashed. This one is less than. It does not have that little or equal to line, which means it is dashed. All right, now we want to put this in the form y equals mx plus b. So right now we have x plus 3y is less than 9. I'm going to go pretty quick through this because it's review. I need y by itself, so I'm going to subtract x from both sides. So 3y is less than negative x plus 9. Y is almost by itself. I just need to divide by 3. And I divide everything by 3. So I end up with y is less than negative 1/3 x plus 3. It is now in slope-intercept form. The y equals mx plus b. What's my y-intercept? Good, you should have said 3. What's my slope? Good, you should have said negative 1/3. So for graphing this, I'm going to put my y-intercept at 3. Again, x and y are labeled, so I make sure I graph it correctly. Now I'm going to make the 1 be the negative number, so I'm going to go down 1 to the right 3. Down 1 to the right 3. You could have also done up 1 to the left 3. Up 1 to the left 3. Personal preference. Now it's important too when you're graphing these that you draw your graph to go all the way out to the edges. That's going to be especially important when we get into the last new section of this unit, which is graphing 2 of these things on the same plane. All right, so now I have all my points lined up, and remember, this is dashed. So I do my dashes a little bit bigger, just so it's really easy to see. Some people like to make theirs like literally little teeny tiny dots all the way across. Your personal preference, just make sure you can tell that it's dashed. Now, if you're wondering, oh my gosh, I accidentally drew it solid and it's supposed to be dashed, what do I do? Number 1, if you did it in pencil, use your eraser and go through and erase little sections to turn it into a dashed line. If you use pen and you have whiteout, go through and put a little bit of whiteout. If you have pen and have none of those other tools at your disposal, just draw a little arrow to it that says this is dashed or supposed to be dashed or dashed line. Do something to indicate that it's supposed to be a dashed line. All right, now step 2, shaded above or below. So looking at the inequality, it's less than. So I would guess it's going to be shaded below since it's less than. But I still want to choose a point to plug in to double check. So again, 0, 0 is available. It's not touching the line. It's always a really nice point to plug in because it cancels out everything. All right, so let's choose 0, 0. Now you can either plug it into this one, how it's written in slope-intercept form, or you can plug it into this one that's written in standard form, your choice. I want you to go ahead and push pause, plug in your point, and then push play when you're ready to check. go ahead and check your answer. I plugged it into both, so I showed the work plugging it into our original equation we were given and the new equation we got when we rewrote it. It does not matter which one you choose to plug it into, because as you can see, you get the same result either way. You should have gotten that when you plug in 0, 0, you get a true statement. Either 0 is smaller than 9 or 0 is smaller than 3. Which means we shade in the direction of 0, 0. Because that's the point we plugged in, and it was true. Now the advantage of this not being glued down yet, I'm going to spin it to shade it in, but you just want to make sure that you shade in the correct section. This is also why I make sure I have my X and Y axis labeled, so that I know when I actually glue it down to my paper, I glue it down the right direction. So if you are one of those people who like shading it in perfectly to a T and filling every single little speck in perfectly, totally fine. If you prefer to do it like this, just make sure I can tell which side of the line it's shaded on. So last but not least, this is shaded here, which is below. Now I also want to point out, this inequality was less than. When you hear less, you think smaller than or below, and it was below. The example before it was greater than. When you hear greater, you think higher, bigger, above. It was above. And the very first example was less than or equal to. When you hear less than, you think smaller than or below. It was below. So I want you to keep that in mind. When your equation or your inequality is written in the correct form, the y equals mx plus b, or your y is written and then your inequality is on the other side, you can use that nifty little trick to determine which direction it's shaded, if it's above or below. All right, that is the end of our notes. Have a good rest of your day.